Hi guys, in this video we'll be discussing the problem of the day for Geeks for Geeks on 4th of January. The problem's name is maximum profit by choosing a subset of intervals. The problem states that given a list intervals of n intervals, the ith element represents S E P and it denotes the starting point S, the ending point E and the profit P earned by choosing the ith interval. So in case we select the ith interval with this starting, ending and profit, so we'll be generating a total profit of P. Find the maximum profit we can achieve by choosing the subset of non-overlapping intervals. So two intervals that are represented by S1 E1 P1 and S2 E2 P2 are said to be overlapping if E1 is less than equal to S2 and S1 is less than S2. So now if that's not clear, I'll start with an example and then it will become more clear. Over here, however, they have not mentioned the expected time complexity, although Geeks for Geeks generally mentions that, but they have skipped it today. But they have mentioned the constraints, so n is less than or equal to 10 to the power 4. They have also mentioned that the starting point of the ith interval is less than the ending point of the ith interval. This is a basic constraint that should be satisfied, and profit earned by choosing any of those intervals would be greater than or equal to 1. That seems good. So with that, let's get started. Let us also take an example. So the example they have provided over here, that is n is equal to 3 and the interval they have provided is 1 2 4 1 5 7 and 2 4 4. Should be good, I guess. So let's start this problem. So we can say that this is the interval A, this is the interval B, this is the interval C. Now if we think about it, we can say that it looks like a graph problem. So we can go from A to B and then from B to C. We can like check all the possibilities and then give a solution to it. However, this is not an optimal solution, and also it's pretty difficult to code. So we have two problems. It's firstly it's difficult to code and it's not even optimal. Not optimal. Now this is not a big problem because you'll find some problems wherein you'll find some questions wherein it's pretty difficult to code, but if it's the optimal solution you'll have to go with it. However, it's not optimal, and this is the reason we won't be following it. Now the reason why it's not optimal is that we'll be checking for all the possibilities. So over here we have n nodes, or we can say we have n intervals. For every interval being present or absent, we have two possibilities, so the total number of possibilities would be 2 to the power n. This is a pretty large number, definitely gonna give us a TLE. Over here we know that n is less than or equal to 10 to the power 4, so yeah, that would give us a TLE. So what's the remaining choice? Now what we can say is that it would make sense if we sort this particular array based on the endpoints. So the time at which this is ending, so we were given with SEP, right? So this basically is the starting point, this is the ending point, this is the profit. What if I sort this particular array based on the endpoints itself or the ending time itself? So if I do that, so the array I'll get is 1 2 4. So just let me write S E and P, and I have 1 5 7, I have 2 4 4. So since this is less than this, so it's going to replace that. So it will be, the first interval would be 1 2 4, the second would be 2 4 4, third interval would be 1 5 7. Now starting at this particular interval, I'll have to check, so whether do I have anything before A. If I'm looking at the interval A, I'll have to check if I have anything before A. No, I don't have anything before A, hence I can proceed further, right? So I'll just write, I'll take maybe a map, I'll write mp2, so that means map such that my endpoint is 2 is 4. So at my endpoint being 2, the maximum profit I can generate as of now, once I've only traversed the A node, is 4. Now I will get to the node 2 or the interval 2. I'll check the values are 2 4 4. So that means if my starting point is 2, my ending point is 4, so this is SE, and the profit is 4. So I can only do that if my starting point is 2. So for my starting point to be true, the last array or the last interval I had selected should end at either 2 or 1 or 0, right? So it cannot be greater than 2. So the non-overlapping arrays mean that if let's say you have a certain interval over here, so it's ending at 3, right? Now your next interval should start at or after 3 only. So if it's less than 3, then it will become overlapping. So let's say the next array was starting at 2 and this was 3, so then there's an overlap between the two, so we can't do that. So we need non-overlapping intervals. Hence what we require over here is, since our starting point is 2 for this for the B interval, hence we require another interval whose ending point was 2 itself. So do we have another interval whose ending point was 2? Yeah. So interval A actually had an ending point 2. So we can say uh, if I'm ending at 4, so if I'm ending at this particular point, I can include the value whatever profit I had from the 8th interval, right, or whatever profit I generated till 2. So the profit generated till the time 2 plus profit that is being fetched by my current interval. So whatever profit is being fetched by my current interval, that's B. So I'll say MP of 4 is 4 plus 4 is equal to 8. Cool. Now we'll get to the next array. We'll see that MP of, so MP just represents map. You can use some other variable. So MP of, it's 5, right? So ending point 5, I'll say what was the profit I could generate for endpoint as 1. So what is the profit I'm able to generate at endpoint 1? Nothing, because even if I want to generate profit from any of the intervals, so the first interval was ending at 2, the second interval is ending 4, so none of the interval was initially ending at 1, so I cannot generate any profit from that, right? So this is 0 basically. So it will say and the profit of the current interval, so it will say that the profit you can generate over here is 7. However, at a previous point itself, so at 4 itself, we were able to generate a profit of 8. So if at 4 we were able to generate a profit of 8, and if at time 5 we are able to generate a profit of only 7, so this is mere stupidity, right? We can actually utilize this particular interval, so we can be idle for this moment and we can say that we generated a total profit of 8 by using the intervals that were used by this particular map or this particular uh, combination. So we can say MP of 5 is equal to max of whatever MP of 5 is, right, comma previous. So whatever profit I'm able to generate till now, or whatever profit I'm generating in this particular point, I have to store that, because I don't want to do any stupidity. I don't want to store anything that's less than what I've already generated, right? So that's it. Now coming to the part how we'll implement it. So the implementation is pretty simple. I've implemented it over here. So firstly we'll have to sort it. Like I said, we'll have to sort it based on the ending time. So in order to sort it based on the ending time, when we generally do a simple sort, so what happens is, in case of C++ specifically, the first element of the array becomes the deciding factor. Over here, however, we wanted the second element of the array, that is the element at the first index, to be the deciding factor, that is the ending point, to be the deciding factor and not the starting point. So what I've done over here is I've given it a comparator function. This is how you give a comparator function in C++, and this is anonymous, so I didn't create another function for it because it just required it at one place, so I directly injected it over here. So what I'm saying is, if the ending points are not equal, then return the lower ending point. But what would happen? So this is a ternary function. What would happen if they're equal? If they're equal, then compare the starting points and return me the lower starting point itself. Now what would happen if even they are equal? Even if they are equal, then return me whosoever has the bigger profit. That I guess makes sense. Then I have a map of profits. Now the reason I'm using a map over here is that map is actually sorted data structure, so it's sorted. So if I'm having a sorted data structure, then I can perform lower bound and upper bound on it. So I had covered lower bound and upper bound in a previous video, but if you have not seen that, so what lower bound gives me is, so lower bound gives of x, let's say, gives me a element that is at least x or greater than x, and upper bound of x gives me a value that is greater than x. So both of them would give me the smallest possible value that is greater than x possible. Well, cool. So because I wanted to use lower bound and upper bound, a natural way of storing it was map itself. So initially what I'm saying is that at time -1, so time -1 technically does not exist, but keeping dummy value so that we can easily check and we don't fall out of bounds. So I'm saying at time -1 the profit I have generated is 0. That makes sense. Also, now I'm iterating through the array that has already been sorted, and I'm writing down the starting point, the ending point, and the profits for ease. And what I'm saying is that the maximum profit could be the one that is generated previously. So I've written previous of upper bound e. So what it gives me is, so when we'll do upper bound for e, so it would give me the arrays that are present, that is having a value greater than e. But as soon as we apply a previous on it, so it will go back. So now it would be giving me a value that is less than or equal to e, right? So that's exactly what we wanted. So we wanted to know that up till this point, was there any way I could have generated some profit? So that value would be present over here now, right? And what I'm doing next is I'm doing the same thing for s. So now I'm saying what is the maximum profit I'm able to generate till s, because if I'm able to generate some profit till my starting point, I can definitely utilize that profit as well and the current profit also, and then I can add them both, right? So this becomes my maximum profit for the current e, for the current ending point. I store that into the map, and at the end I simply return the last element of the map. I've done it in this way. You can actually change it a bit. You can say it's our begin and second. This should also work the same, I guess. Yeah, let's try to submit this. And you can see the code ran in 0.25 seconds. It had 131 test cases in total and all of them passed. And this was an easy question, although it requires DP and sorting, but still I consider it to be somewhat easy question. I guess you got the gist of it and are able to code it. If you need any other help, you can let me know in the comment section below. Thanks a lot, guys.